Aoife, I'm going to go through the solutions of these simultaneous equations with you. Now, there's always more than one way to do simultaneous equations, so I apologize if I'm doing this differently to how you've learned in school. Just let me know and I can try and do it a different way. But basically, the trick to simultaneous equations is you can add them. You can add the like terms. So I can add the 13y and the 3y. I'd get 16y. I can add the 6 and the 2. And I can add the 14 and the minus 4. But that won't do me any good if I do that, because I'll still just end up with a third equation with x and y in it. So what I need to do is change these equations so that one of the variables, either the x's or the y's, will cancel. And how do I do that? Well, if I had a minus 14 here, then these would definitely cancel, wouldn't they? Because 14, take 14 gives me 0. So what I'm going to try to do is figure out a number that both 14 and 4 divide into. And hopefully you can see that that number is 28. So I'm going to write down what I'm going to do. I pick whether I'm going to cancel the x's or the y's. I'm going to cancel x. And the way I'm going to do that is I'm going to get 28 in front of each one. That's what I need to do. And I need 28 in front of one and minus 28 in front of the other. And maybe you remember the name for the number in front of a variable is a coefficient. So I want the coefficient of x in my first equation to be 28, and I want the coefficient of x in my second equation to be minus 28. How do I do that? Well, if I multiplied 14 by 2, I'd get 28. And if I multiplied minus 4 by 7, I'll get minus 28. So that's what I'm going to do. I'm going to cancel x by multiplying my first equation by 2. But I can't just multiply, sorry about the Ben and Holly in the background, I can't just multiply the x term by 2. I have to multiply every single part of my equation by 2. Tristan, could you turn that down a little bit, please? Thanks. Because you can do whatever you want to an equation so long as you do the same thing to both sides of the equation. So here's what I get. When I multiply 13y by 2, I get 26y equal to, the 6 gets multiplied by 2 and I get 12, and the 14 gets multiplied by 2 to give me 28x. Now that is the same statement, the same truthful statement as I had here. Why is that? Because if I say that 2 is equal to x, then 2x is equal to 4x. So you can multiply things by 2 like that. The second thing I said I was going to do was I was going to multiply my second equation by 7. So 7 times my second equation gives me 7 times 3y, 21y, equal to 7 times 2 is 14. 7 times a minus 4 is minus 28. And now I can add my like terms. Even though I've got two different equations, I can add the terms that are in them. And if you don't understand why that's true, I can go over that in another video for you. So 26 plus 21 is 47. 47y equals 12 plus 14 is 26. And these guys cancel to give me 0. So what I've learned is that 47y is equal to 26. So how do I get y on its own? Well, again, I can do whatever I want to an equation so long as I do it to both sides. I divide this side by 47 and I get 1y. And I divide this side by 47 and I get 26 over 47. So I get a fraction answer, and that's what we were expecting looking at the picture that you gave me. Okay, what do we do now? You've two options. You can go back to the equations and cancel the y terms and find the x value, or you can replace y in either of these two equations here. So I'm going to sub in y equal to 26 over 47 instead of y. In my second equation, it actually doesn't matter which one I do. So instead of 3 times y, I'll now have 3 times 26 over 47 equal to 2 minus 4x. You can use your calculator to work out the fraction, or you can do it using calculator or using fraction methods. Tristan, can you take her, please, just till I'm finished this? So 3 by 26 over 47. You can see I've got exactly what I've written down there. Gives me 78 over 47. 78 over 47 equals 2 minus 4x. Now I want to solve this, and it's no different to what we've done before, even when we don't have fractions. I bring my letter terms to the left and my number terms to the right, and when I change sides, I change signs. So my minus 4x comes over and becomes a plus 4x. 2 stays where it is, letters left, numbers right. 78 over 47 comes over and becomes negative. So again, you can use fraction methods for taking that from 2, or you can use your calculator. So the calculator should do this for you, and it's just saving time. It's good if you can understand how to do this without a calculator, but if you're in a rush, you can use the calculator to do it. And we get 16 over 47. So 4x is equal to 16 over 47. But I don't want 4x's, I want just 1x. So I divide both sides of my equation by 4. 4 divided by 4 is 1x. And 16 divided by 47, and then divided by 4, I've got the answer still in my calculator. Divided by 4 gives me 4 over 47. And that's my second answer. They wanted your answers to be left as fractions. So just leave it as a fraction like that. Okay, I hope that made sense to you. If there's a step you don't understand, please let me know and I'll go over it again. Or if you normally do your simultaneous equations differently, let me know that as well, because there are different ways of answering questions like this. Okay, thank you.